In this recording, we're going to learn about a unit circle. So as it says in the intro here, the basis of trigonometry will be this unit circle. And this will lead to our special triangles. It will also lead to our graphs of trig functions, the sine and cosine graphs. And this unit circle is basically a circle with a radius of 1, and its center is at the origin. That's why we call it a unit circle, because it has a radius of 1. So which of the following could be that? Why don't you look this over and play the recording when you have your answer? Okay, so hopefully you looked at this and said, nope, that's a line. Nope, that's a parabola. Well, this one has some potential. It has both variables squared. Well, this is also a circle, but its center is at 1, 1, because it's x minus k. Remember those transformations that we looked at? If it's inside the parentheses, it means it shifts to the right 1, and this one shifts up 1 in this case, so the center is at 1, 1, so that's no good. This is our unit circle right here. So let's look at two very special triangles. These are the two important triangles that I'm going to need us to know in order to find exact values of trig functions, like sine of 45 degrees or cosine of 60 degrees or something like that. So we have this isosceles triangle, this 45, 45, 90 triangle. Let's use the Pythagorean theorem to try to solve for the unknown side. We're going to consider the hypotenuse of both of these special triangles. You can see the bottom one here to be a 1. That way they can be placed on the unit circle such that the hypotenuse is the radius of the triangle. And I'll just preview. On your next page you can kind of see that. Okay, so I'd basically be putting this triangle, the 30, 60, 90 triangle on its side, the 30, 60, 90 triangle standing tall, or the 45, 45, 90 triangle. Okay, in all cases, the radius is a 1. So back to our two triangles here. Let's do some algebra. Why don't you set up a Pythagorean theorem equation representing the relationship of those sides, and then solve it as far as you can, and then play the recording for some help. Okay, so hopefully you did this. If you did not, please do it. X squared plus x squared equals 1 squared. That's the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. See if you can proceed with this. If you can't, play the recording. Okay, so combine like terms. We've got a 2x squared equals 1. Divide both sides by 2. X squared equals half. Now we've got to get x by itself, so let's square root, and the left side becomes the absolute value of x. Remember that from your Algebra 2 course. When we square root a square, we don't get x, we get the absolute value of x. And over on the right side, we get square root of 1 over the square root of 2. I can physically distribute the square root to the numerator and denominator. So the absolute value could have been a positive or a negative. So we'll say the absolute value of x equals plus or minus. Well, let's work with this a little bit. Square root of 1 is just 1, right? Square root of 2, I got to do something with this. It's not considered simplified form. So what I'm going to do is rationalize the denominator. I know you heard about this in Algebra 2, but you forgot about it. So let me help you with it. We're going to multiply by the square root of 2 over the square root of 2. What this does is the denominator becomes rational, because the square root of 2 times the square root of 2 is the square root of 4, right? So that's just a 2. So the denominator is just a 2. The numerator is 1 times the square root of 2, which is square root of 2. I'm going to reject the negative root here because that can't be a side length. So that's the value of x on a 45, 45, 90 triangle. Second triangle is a 30, 60, 90 triangle. Hypotenuse is 1. It's half of an equilateral triangle. So let's sort of drawing a dotted equilateral triangle here. Okay, so if you use your imagination, there's a equilateral triangle with ones all the way around. So if this entire base is 1, obviously half of that would be half. So the shorter side is half. Hopefully that makes sense to you. Now we're going to use the Pythagorean theorem one more time. Let's call this side x and use the Pythagorean theorem to solve for x. So please play the recording after you've had a chance to work this out. Okay, so hopefully you took time to do this. If not, please do it now. X squared plus half squared, that should be in parentheses, equals 1 squared. Now we just got to do the algebra to solve for x. So x squared plus a quarter is equal to 1. Subtract the quarter and we have 3/4. Okay, just like before, we're going to square root both sides to undo the squaring. So the square root of x squared is the absolute value of x. Okay, this is something we're going to really emphasize here. Square root of 3 over square root of 4. Well, the square root of 3 and the square root of 4. Nicely, the square root of 4 is one that I know. We'll use that in a moment. So we said the absolute value of x means we have a positive or negative value of x that could produce. And the square root of 3 is over a 2 because the square root of 4 is obviously 2. Reject the negative root. We don't need that. So let's just get rid of that negative root. I'm going to erase it. We just have the positive root. So this triangle here is a square root of 3 over 2 across from the 60, the bigger side, and 30 degrees has the half across from it. Okay, so what we're going to do is for these 16 key angles, 0, 30, 45, 60, etc., we're going to find out the coordinates on the unit circle. This is a crucial step. And we're just going to use those special triangles. Hopefully you can see this 30, 60, 90 triangle right in here. And then hopefully you can also see the 45, 45, 90 triangle. And hopefully you also can see the 30, 60, 90 standing vertically here. All right, so we've got those 3 triangles. Therefore, we know the x and y. So let's take on that green one. The green one, we know the hypotenuse is a 1. Okay. And if this angle here is 30 degrees, across from the 30 degree angle, well, what was that? Let's go back and see. So across from the 30 degree angle, remember it's half. And across from the 60 degree angle is square root of 3 over 2. So let's put that in. So if this side across from the 30 degrees is half, and this side across from the 60 degrees, let's put a little 60 in here, a little 30, is square root of 3 over 2, well then its coordinates, in other words, the x coordinate of this triangle has to be the radical 3 over 2, right? And the vertical side, the y of this triangle, makes up the y of that point, the height of it. So that would be half. Okay, let's do the same for the blue triangle. So flip your paper around and see what the sides of the blue triangle should be, the 45-45 triangle. Hopefully you saw that the vertical side is square root of 2 over 2, and so is the horizontal side. So that means both the x and the y are square root of 2 over 2. I wanted that to be blue. Let's see if we can get that. And notice they're all positive here because the y's and the x's in the first quadrant are all positives. Just go ahead and label our quadrants. All right, and finally the red triangle. So now the x's and the y's have switched, right? The x coordinate is the half, and the y coordinate is the root 3 over 2. So the x is half. Y is root 3 over 2. Finally, when we get to the 90, well, the 90, that's a unit circle, so it has an x of 0 and a y of 1. Okay. Turns out the rest of this, we should start out with this one. This one had an x-coordinate of 1 and a y-coordinate of 0, right? So, kind of moving across, there's a lot of symmetry here. So without having to reproduce all our triangles, we've got across from this point right here has the same y value, but its x value is negative. So this should be negative 1/2, comma, square root of 3 over 2. In other words, the x is negative, it went to the left. The y is still positive, it went vertically. Okay, so at this point, let's see if you can fill in the remaining 3 angles here, the 135, 150, and 180, and then play the recording when you're ready. Okay, so hopefully you came up with negative square root of 2 over 2, comma, square root of 2 over 2. And then for the 150, it's the same as this one. The x is negated, but the y is the same. Now when you get to the 180, hopefully you nailed that one as well. The x is a negative 1, and the y is a 0, right? It didn't go up at all. Okay? Now we're down into these. These are the same, but reflected in the x-axis. So as I reflect this down, this point has the same x-coordinate, but the y value is negated. And I realized I made a little mistake here. This should be a negative. They all are negative in the third quadrant, both the x and y, because it went left and down. All right, and let's finish it out. This point right here has an x-coordinate of 0 and a y-coordinate of negative 1. And in quadrant 4, we're just taking our points from above here, and we're negating the y value, but the x value is still the same. Notice there's only a handful of numbers that were used every time, because they're all based on these 2 special triangles. So either it's a half, a root 2 over 2, or a root 3 over 2, or we're on what's called a quadrantal angle, the ones that are right on the axes, a 0, 90, or 180, 270, and those are all 1s and 0s and negative 1s, right? So there's only a small subset of the numbers that are used here. They keep getting repeated. Okay? So let me give you a little work time. You've got a couple here to convert into degrees from radians, and then these you just need to find out where that angle is and say what its coordinate is. So play the recording to check your answers. All right, so hopefully you worked those out. We'll get some answers here. This one is the same as 240. It's going negative, and so that next one is the same as 135 when you take out a full rotation. Next one we need to do a little conversion, so that's a nice review. We're going to call this pi radians over 3 times the unit rate of 180 degrees over pi radians. So we want the radians to divide out, which they do. So we're just left with degrees. Pi divides out. 3 and 180 degrees divides out 60 degrees. So, and 60 degrees, you can peek out where that one is. 1/2 comma root 3 over 2. And finally, convert this into radians and play the recording when you're ready. And at 270, it's just 0, 1. Sorry, 0, negative 1. Thanks for watching.